Sure. Sounds good.
And we are live.
All right. Okay.
Awesome.
Awesome. Good evening, everybody. How many followers do we have right now?
0 currently.
I mean, sorry, viewers. But Jen Armstrong says 22.
Maybe mine is a little
20.
delayed.
I see 20.
Oh yeah, well 20. Okay.
Okay, so apparently there are 20 people watching. Hello to the 20 watching. My name is Andrew. A lot of you probably know me already. I am with the new developers. We are a student-run club at Mohawk College. Before we get any further, I would like to direct you to the GitHub repo for the code that Jenifer Champagne is going to be using in her tutorial tonight. So Jen Armstrong is going to drop that URL in the chat on the right. If anyone's new to Twitch, you want to click the chat link below the screen to get that chat pane up on the right so you can see what people are typing into the chat, okay? So Jen Armstrong has dropped a GitHub URL in there. Please go there and download the code if you want to walk through and check it out. So while you're doing that, I would like to just quickly tell you about the new developers. For those of you who don't know us, we've been around for about 1.5 years now at Mohawk. We try to provide events, talks, workshops, and things to build skills for the C-State students to get jobs. And talks like we have tonight with Jenifer Champagne to work on technical skills are something we love doing because we running the event also get to learn something tonight, which is great. So if you are a Mohawk student watching this tonight, and if you have not yet joined the Mohawk C-State Discord server, this is something we like to let everybody know about because it's a very useful communication platform that over 300 C-State students at Mohawk are on right now. You can go on there for help with your assignments in your courses. You can go on there to make some social connections. It's a very active server with a lot of people on there. And if you would like to join, we can send you an invitation link to the server. All you have to do is email us. And Jen Armstrong, could you please drop the email address into the chat? She did. Nice. Okay, good. So yeah, please just drop us an email and let us know you'd like to get on the Discord. Also, if you'd like to be on the new developers mailing list, Jen, can you please give us the URL for that? You can sign up to our mailing list. You'll get direct emails about upcoming events, upcoming workshops, social events, and so forth. We also have a new developers site. And if, Jen, you could drop the URL for that in the chat. We also try to keep that updated with information about events. And what else? You can follow us on Twitter. I think it's at TND Mohawk. Yeah, Jen's gonna drop that in the chat. Yeah. Okay, here she goes. Oh la la, yeah. Okay, and also
getting a little ahead of myself.
You can also follow us. Oh, the Facebook is in there too. So we've got a Facebook group. You can join that, and we post in there about upcoming events as well. So please contact us, stay in touch with us. Anybody who's not a Mohawk student, you're also welcome to contact us if you'd like to know more about our club or what's going on with C-State at Mohawk, anything like that. We welcome connections with anyone in the development community. So tonight's event, as I said, is Jenifer Champagne doing a code tutorial for us. She has provided a video for the main tutorial. We'll be watching that online, and she'll be working with the code that you can get from the GitHub repo, which if you're just joining us, there is a URL in the chat to go and get that code from GitHub and take a look at it as we're going through. After the video, Jenifer will be doing some live Q&A on camera, so you'll have a chance to ask her questions about anything. By now, there isn't much point to me building up an intro to Jenifer Champagne. You've heard her name over and over. You see her on the screen. But I would just like to mention that Jenifer is one of the most experienced coders that I've had the pleasure to meet. And she is well known in the Hamilton development community. I've seen her give talks at different meetups like Coder Camp and Hamlet.js, and she's probably given a lot of talks that I haven't seen. We were very lucky to have her do talk on freelancing as a developer earlier this year, which was excellent. And if you have a chance, check it out. It's on our YouTube channel, which is linked on the Twitch channel here. It was excellent, and she's a wealth of knowledge, and we love having her here. Ladies and gentlemen, I'd like to turn it over to Jenifer Champagne.
Thank you for that. I'm always feeling humble, but I appreciate that. So my name is, as mentioned a couple dozen times maybe, Jenifer Champagne. I work at Weever Apps as a software developer and team lead. I've been kind of getting into a lot of Rust lately, and I've become a bit of an evangelist for it, I think. So I've, of course, been talking about it with everyone I can possibly talk to about it, and the new developers were like, hey, can you talk about it? So talking is the best thing I can do. Trying to pre-record a video because I don't really trust myself for live coding turned into an hour-and-a-half video when I didn't even get a chance to cover all the things that I wanted to cover. But I do think that it should be a good starting point for the first part's probably a little bit slow. I'm talking about the syntax, but then we get into making a little REST API with a few endpoints where it's basically a to-do app, but using a good library with Rust. So I'm going to be in the chat. If anyone has any questions, feel free to throw them in the chat, and I'll be answering along the way. If there's any big things that come up, then we'll probably pause the video. I'll step in and kind of explain things or show code or whatever it may be. But yeah, as mentioned, once it's over, we'll have a little Q&A at the end. So whether you have questions for the end or questions during, I'll be here for that. Shall we get started?
Nice. Yeah, we just got another follower as well. Thank you for following us.
Okay, so Rodney's driving now.
Alrighty. So now starting with my empty VS Code window, you can see I'm already in a folder for this project. So what I'm going to first use is a tool called Cargo that comes with Rust. This is a package manager of sorts, so it can be used to create our application, to initialize it, to add dependencies and that sort of thing. It works a lot like NPM in Node.js, if you're familiar with that. So in this case, cargo init. I could put a -- bin. That is, for the most part, optional. That would specify that we want a binary application that we want to be able to run, which we will want to in this case. But I figured I'd mention it because we could also specify lib, and that's where we're creating a library where we're not making an executable application, but we're packaging up code to be used elsewhere. A lot of Rust packages are kind of designed that way in that they have lots of little small chunks that are a little more interoperable. Nice and modular. So in this case, I want to initialize a project, and I'm just going to put a period to specify the directory I'm in. It'll take the directory name as the project name. Otherwise, I could specify whatever name of a project I want, but it'll create a folder of that name. So since I'm already in the folder, I'll just use the dot. Okay. So with that out of the way, I've got my Rust application here. The cargo.toml file is a lot like a package.json, or it's just kind of our specification of what the application is that we have and what dependencies it might contain. Right now we can see there's none, but we'll be adding to this in a bit. The other thing you'll note is that we have a function main, and the function main is what gets run when we run the application, and it will print hello world. We'll kind of get into some of these function calls and some of the syntax lightly, but for now, if I were to say cargo build, we can see that it has built in the target folder under debug, because debug's by default not optimized. We can see here unoptimized and debug info in the terminal.
So in this case, right here, basic Rocket web server is the binary application. So technically, I could use the cargo toolchain and say cargo run, and we could see I get my hello world. Or I could be more explicit and say I want to run the target debug application of basic Rocket web server, and we see that it doesn't rebuild it or anything, it just executes the application. All right, so with that out of the way, let's add a dependency. So in this case, I'm going to put cargo add rocket. And one of the things that you'll see with Rocket in particular, most packages are totally available in the public Rust toolchain. Some, like Rocket, require the nightly version of Rust because it's using some features that are not fully fleshed out in a way that's generic enough for it to be fully public, I guess you could say. But in this case, if I were to, for example, actually, first, let's add the bit of boilerplate code that comes from Rocket itself, just so that way we can kind of have a starting point to go off of, and I'll kind of walk through what each of these pieces do before we kind of continue on. Okay, so now if I were to try to build this again, we can see I get a bunch of errors, particularly this pair requires a dev or nightly version of Rust. So in this case, what I'm going to need to do, this is something you'll notice with Rust, is that the compiler is designed to be very helpful, almost like a pair programmer. So don't feel afraid of the errors. Don't feel like, oh, it's just a bunch of errors, I'm not going to read them. There is generally very useful information in the output that it produces. So there's a couple different ways to specify that you want nightly in this folder. I personally like to create a file that is rust-toolchain, and then within that I can specify nightly. If I have a specific version of nightly, since nightly is daily, I could specify, for example, 2020 November 15th. And what it would do is it would then fetch all the dependencies it needs, fetch everything it needs but the nightly version of those. That doesn't necessarily mean that all of these are different code than we would have used in the non-nightly, just that it's recompiling them with the Rust base language that is with nightly features. Build times are a common complaint, so hopefully you don't feel that burn too much. It's usually pretty good about not recompiling things unless necessary, but slower, older machines will see this more. There's a person I know who did their first attempt at working with Rust on a Raspberry Pi, and the compile times were unbearable from what I've heard. Alright, everything is compiled. We see I didn't get any errors this time. So if I were to say cargo run, we can see that I've got my web server running here. I'm just going to do the split terminal so that I can have two little terminals going on here, so that way I can actually test that index endpoint. So let's do a curl of our URL on our correct port, and we see the response of our hello world, which if I go back to, actually before I do that, I'm just going to take the date off of it, keep it as just nightly, and another thing what I'm going to do, I just hit Control-C to cancel out of that, but what I'm actually going to do is use another tool called Cargo Watch, and in this case what it's going to do is automatically rerun the application every time that I make a file change. You can see everything is recompiling. It's only recompiling because I took the date out of nightly. That is now telling it to use the current date, which at the time of recording is not the same as the date I just typed in, so that's why it's forcing it to rebuild. You'll see as we go that those compile times won't be quite as bad. I believe this unresolved error. Yeah. As soon as we have this fully built and resave the file, we'll see this go away. The extension I'm using, by the way, let's see if I can find it. Yeah, I believe it's called the Rust Analyzer. There it is, Rust-Analyzer. So this application runs a server that's constantly basically compiling your application and running your code through it, so it'll give you nice annotations like this. So highly recommend this extension. All right, web server's running, and we can see that that Rust Analyzer is now also running a bit of a build, so that way, since we've just changed the version, it had to rebuild. It's only going to let you rebuild in one area at one time because it blocks, but that will catch up shortly. Okay, let's see. Or maybe I will need to close it. Yep, okay. Closing and reopening did it. Always good to turn it off and on again. So, what do these things do? The first one here is entirely, this first line is what we needed nightly Rust for. This is giving us some tools that allow us to do this type of annotation, which is called a decorator. So I might as well explain the decorator first. In this case, anytime you see a number sign and then square brackets, what we're basically saying is that we're going to execute this function with it receiving an argument of whatever it is preceding. So in this case, we're using a handy get macro that's provided by Rocket that's going to turn this function into a get endpoint. There are lots of different ones, but anytime you see something like that, basically it's saying that it's going to take the next thing that comes after it and it's going to do some pre-processing on it before it actually does the full compile. So it's changing the code for us. So in this case, this macro use is specifying that everything that comes with all the macros and decorator functions contained within Rocket, the library, should be imported into our project. That's how we have access to get. And this right here, this first line going back to that, that is that special new type of procedural macros, which is what kind of gives us the power that you'll see we're able to do with these endpoints. All right, let's talk about some syntax. So in this case, I've already mentioned about our decorators, and I kind of mentioned that this was our function main, so fn is the keyword to specify when something is a function. The let keyword lets us define a variable, so I can say let value equals 1. Rust is a strongly typed language, but it does a lot of inference for us. So in this case, it already knows that it is a 32-bit integer. In order to specify something like an unsigned 64-bit integer, in that case, I can append that to the end of the value, and it's currently telling me it's not used, but we can see that the correct type is specified for value. It tries to do a lot of this type of checking and making sure that things are valid. So as an example, if I were to specify, instead of allowing inference, I could say, oh, well, this is supposed to be a string. And now at this point, it's going to give me a compiler error. And if I expand this a little bit just so we can see it more clearly, maybe I'll do it this way temporarily. Okay. So we can take a look at this error message, and we can see that it's very nice and descriptive, telling us what file, what line, what character that the error happened at, that due to this, it expected a string. However, it turned out to be an unsigned 64-bit integer. And so it's even giving us a helpful tip of, oh, if you meant to convert that to a string, that we can put a .toString at the end of it. Since everything is a proper type and not a raw value, like in certain other languages, we can see that we're always able to put we can always call methods upon values. So minimize this now, and that's kind of what's going on there. This rocket here, actually no. Let me see. Okay, so with that, that's kind of how variables work, that's how functions work, and you can see here in this function definition, we've got an arrow and then an ampersand, bunch of stuff. What this is saying is that this function returns this type. A lot of the time, even though we have the type inference, where, for example, here I don't need to specify what something is, when it comes to function calls, you must be very explicit about what it takes in and what it returns. The fact that main has no arrow here means that it returns nothing. So now, a couple of the little notes, you've probably seen that in most places there are semicolons, and in some places there are not semicolons. Big part of that has to do with every line effectively needs to have a semicolon unless it's returning a value. So in this case, we could be writing, for example, return and then have a semicolon. This would absolutely work. That is not encouraged, but it's totally valid. So one thing that Rust gives us by default is that we can instead leave off the semicolon, and that implies that it's going to return that value so long as it is the final statement within a function. So for example, I couldn't have let something equals 1 here, and then over here I'm going to do another thing. Let other thing equals 2. We're going to get an error. But as long as it's the final statement, then that's what's going to get returned. So keep that in mind when you see syntax where there is not a semicolon versus when there is a semicolon. That's kind of where those differences lie. And I don't think we overly need to see the console at the moment, so I will minimize that. There we go. Okay, so in this case, we could remove this value. That's kind of some of the core bits of syntax. I already kind of mentioned that every value can optionally have methods attached to it. So in this case, our rocket ignite, which anytime you see the double colon, what that is basically specifying is that we're accessing something contained within that module or structure. So in this case, rocket is our dependency rocket, which we saw in our cargo.toml. And so in this case, I'm saying within that dependency, call the static function ignite. It's returning a type of rocket we can see here, capital R rocket, and that type has a .mount that allows us to specify all of the routes we want to attach, and then it has, we can see actually that the mount function here takes some vector of routes. We can see it has the self, and that's why we have the dot operator. So it has the self specifying the base variable. It's got the base route string, which actually I should mention about those strings in a second. And then it's taking the R type, which R here is saying it's taking a vector of routes. And a vector in Rust is effectively a dynamic array. I believe that's a C++ism of vec. I can't quite remember for sure. But the idea is that there are two types of strings, there are two types of arrays. The vec is the dynamic array that we can change at runtime. A slice is an array that we cannot change. And then it returns self. So then we're able to call launch on rocket, and that will potentially return an error, but we're ignoring the return value in this case. Now, I mentioned there are two types of arrays. So just to kind of specify that quickly, if I were to say let slice equals 1, 2, 3, that is a slice of 32-bit integers. We can't in our code say, oh, add something to that slice, but a slice gives us some optimizations where we can very efficiently iterate through the values within that. Alternatively, what most of us probably think of as an array would be a vec, and in this case I have a say new, I just want an empty vector, and now I'm able to push like we push in most other languages. So push a 1, push a 2, push a 3. Oh, let's see. Yes. So by default within Rust, every variable is immutable. So it can get a little confusing because structures can mutate within themselves, but for the moment, anytime I know that something is going to be changing, I need to put the word mute in front of that declaration. So in this case, once I do that, I'm saying that this array mutates, it changes, and so now I'm able to actually make changes to it in the code. Similarly, there are two types of string, and the basic type of str string, which I'll just put, let's see, basic string is a plain string, and we can see that over here. So I'm going to say hello. So in this case, once I save this, we can see that it is a type of ampersand stir. So what this is doing is an str string is really a string slice. So just like we were seeing with the array, this is a lot the same as specifying this is a slice containing these 6 letters. That's what that is. And the ampersand is saying it's a reference to. So in this case, I think a moment ago I had showed a capital S string. So let's put string object. And I will say that we want it to be a string from, in this case, and I'll put my regular string slice. And so now this is a capital S string. This is just in the same way where we had an array slice, an array vec. These are static. They are a set of characters. So you're not going to be manipulating the string. You're not generally going to be modifying in that way, whereas this string is a dynamic string, allocating at runtime, being able to create them arbitrarily as needed. You wouldn't be creating string slices at runtime, but you can absolutely create a string object and then convert it to a string slice, which then we can see now they're both string slices. So there's lots of flexibility. It just, there ends up being a lot of this in between of compile time and runtime. All right. So I've pointed out the ampersand a couple times right here, and I kind of want to explain what this is. So just like how I was saying, one of the big things that you need to be explicit about is compile time versus runtime. Compile time being when we generate the application, runtime being while we're running it. There's also a distinction between moving memory and referencing memory. So this gets explained as lifetimes and borrowing. Lifetimes referring to the lifetime of a variable, how long it should be stored before it gets deleted, and borrowing is all about ownership and who owns values. That kind of comes into play with preventing data races or preventing different threads from corrupting data. So Rust is pretty strict when it comes to those things. I don't find it to be something that's too complicated, but it does tend to be a bit of a stumbling block, so I kind of wanted to mention a little bit about it. So if we're talking about lifetimes, one of the things that may be odd about that concept is that in some low-level languages, which Rust is, you end up needing to manage memory yourself. And that, honestly, Microsoft themselves have released a statement a while back, years ago, basically stating that 70% of the security vulnerabilities they deal with tend to be memory mismanagement or memory errors. And so that was actually a big part of why Rust was created in the first place, was to prevent multi-threaded problems, data races, things like that, and also memory problems. So memory is a big thing, but you'll notice that a lot of languages like C#, Ruby on Rails, PHP, JavaScript, a lot of these languages, they don't make you actually deal with memory. You just create variables like we have been creating variables here. The reason for that is they use something called a garbage collector. So it will sit around and try to keep track of which variables you're using, and when it thinks you're done using them, it will periodically go through a flush and delete a bunch of memory. Depending on your application, I would say most of the time that probably doesn't matter and works perfectly fine for most use cases. Occasionally you will find situations where that ends up with problems where it happens to be processing at an inconvenient time, or your memory is ballooning up too quick before the garbage collector can clean things out, etc., etc. So in some cases, you may not want that. Rust instead follows something, a concept that's kind of similar in C++, but they've taken it up a level, which is where it keeps track of the lifetime of variables. So for instance, it sees that this value is never used beyond this line, and so I won't say that it gets deallocated immediately here, but it understands that the life of this value ends here. So it's going to try to intelligently decide when in the code that should be freed, when it should be deleted, but that decision is made at compile time, not at runtime. So there is no garbage collector, there is no runtime, there is no event loop or different things going on. That's part of what makes these Rust applications so efficient. As a comparison, where I work at Weever, we have 2 API applications, and granted, one is much larger with a lot more going on than the newer one that we have.
Okay, so we paused it, and I think you guys want to talk about garbage collection?
Yeah, just briefly. Because there's a question about garbage collectors, and I don't think I'd be able to explain that typing super easily. So to be clear, Rust is a language that does not have a garbage collector, and that's kind of an advantage in a certain sense. So a garbage collector is usually, when you use a language like JavaScript or C#, what you'll end up having is this sub-process that is constantly watching how many references you have to every variable. And periodically, what it'll do is it will do a flush through all of them. So it'll go through every single variable that's currently in your program, and it'll say how many different functions, how many different areas of your code are actively using it or actively referring to it. And for anything that count is 0, it will deallocate that. So that's kind of the way that it manages that memory for you, so you don't have to think about it. In a lot of ways, that's fantastic. Usually what that ends up meaning is that you'll end up with a lot of memory being used that you're not technically using until that garbage collector goes. And sometimes, even in certain languages, what will happen is your program will slow down at the time of cycling through and going through that garbage collection process. But since you don't have control over that, the garbage collector is usually just going to happen whenever it's going to happen. I think in Go, you can manually choose when it's going to do that so that you can pick a good time. Probably most languages do have that, but it becomes this thing where if you need really tight performance, if you need to manage memory super efficiently, you can think of like working with electronics. So working with small microprocessors, microcontrollers, Rust does really well in those because it doesn't have that runtime. It doesn't have all these extra things happening in the background. The code you write is the code that more or less ends up in the application at the end. And so it uses this technique of, rather than counting how many references we have to stuff and dealing with it later, at compile time, it will look at all of your variables and determine when you're not using them anymore and deallocate in place. So I mentioned that C++ has something similar. And the thing in C++ is called RAII, Resource Allocation, and I forget the II. But the idea is that you don't worry about deallocation, and it will automatically deallocate at the end of a function call, wherever something is defined. But then the problem is, if you need something to live longer, you have to manually allocate it, and you may end up in a situation where that's existing in the heap, and now it's up to you to manage it. So it's like it will help you in some cases, but it won't help you in all cases. So Rust is super duper strict about how long things live, so that way it can guarantee parallel processing will never have memory problems.
Can I just jump in here? And there were a couple of good questions that came up, but maybe we could just handle them before we start the video again. So Zephad Prof, who asked a lot about the garbage collection, also asked specifically, are all local variables on the stack or heap?
The stack. So by default, everything will be on the stack. The way that Rust kind of does it is that there are special classes we can use to wrap things. So one is called a box, for example. So if you were to write, for example, capital B box, : new, and then your parentheses and whatever you give it, that box is a heap allocation. So there are ways that you wrap things that tell Rust to put it in the heap. By default, everything is in the stack. Same thing with, for example, if you wanted some number that could go across threads. So normally you would need to make sure that it's safe to do that, that you're having, whether it's reference counting or whatever. So there's something called an arc, and same sort of thing. So you would just put capital ARC : new, and whatever variable you give it, it is an atomic reference counted heap allocation. So there's all these like little helpful wrapper objects in Struct. And those are the only ways that you ever put anything into the heap.
Cool. One more question I'd like to point out. Arctic is asking, is there any notable disadvantages to Rust's way of handling this? And I assume he's talking about the garbage collection.
So really, it's just about, because it's so strict, that could be complicated. The lifetimes and borrowing system is considered the most difficult part about Rust. And I'll even admit that there are times when it gets super complex for me. Because if you don't care too much about memory, and for example, when we're just writing code in a function, like in this video, you just don't worry about it. You allocate what you need, it gets deallocated. When you start making your own structures, which are basically kind of like classes, when you start making your own, now you need to use generics to start specifying, okay, this variable has to live this long, this function input that came in here, well, I'm making that part of my structure, so I need to say that that lives the same lifetime as my whole structure, or this one I'm copying, so I don't need it anymore. That's really where the complexity happens. So if you don't want that complexity, then that's kind of where the disadvantage is. Rust forces you to deal with a lot of stuff at compile time. I would say when you get used to it, then it's not that really big of a deal, because Like myself, I find myself faster coding Rust than other languages. But when you're just getting started, that's a massive barrier when you can go into another language, just allocate something, and you know a garbage collector is going to deal with it for you.
Right. Cool. Okay. Thank you.
All right, so we'll go back to the video now.
But the original one is built in Node.js, and the newer one is built in Rust. And the difference in performance, the difference in memory usage, the difference in all of those things is fairly extreme. I don't have the numbers offhand, but I know the Node.js server can be anywhere from, I believe, somewhere in the range of 500 megabytes up to 2 gigabytes of RAM usage, depending on what it's doing, depending on that sort of stuff. Whereas the monitoring we've had of the Rust one so far has never exceeded, I think, something like 50 megabytes of memory usage. When it's idling, it's using an extremely tiny amount of memory. That's the benefit we get of all of this processing being done at compile time versus here's some scripts, run it through the runtime. Okay, so that's lifetimes. And then there is the concept of ownership and borrowing. So normally in a lot of languages, like JavaScript, for example, basic values like Boolean, like string, they don't, they would copy the value. You wouldn't be referring to the same value, but any object, any array, if you were to type it out and say pass an array to one function and the function adds to that array, you will find that the array you passed in, even if you expected your array to still be exactly as you had it originally, you'd find it's modified. And that's because by default, everything is referencing the same object in memory. So that's one of the things that Rust is going to keep track of for us. So in this case, let's say, for sake of argument, I'm going to make a new function. I'm going to say, we'll call this say a thing. And it's not going to return anything, but what it's going to do is it's going to go back to that print line function that I had showed originally when we created the project. And actually, I want to specify, we're going to take a variable, we'll say a string slice, since that's kind of what we've been working with. So we'll just give it a terrible letter name of s and say it is a string slice. And in this case, I am echoing that out. So the curly braces mean that it's going to take whatever that variable is and put it into the string. So I could say s equals, and it will insert that value here. Okay, so I've got my function that is going to, actually this is a terrible example. Let's change this to a proper string. And the reason is because the string slice is already a reference. The whole point is I'm trying to explain those differences. So in this case, we're taking a full string. So I will take this conversion to string slice off, and I'm going to say a thing of s, which s in this case is, oops, not say a thing, it is string object. So now if I go back to my terminal, see it's building, and right here we got s equals goodbye, and that matches up. That's the value I expect it to be. But now let's just say I wanted to, effectively, I want to do some more work with this. So I want to make another string. The print line is just convenient in this case. Was what was said. And in this case, I'll put my variable again. So if I run this, we see I get an error. And so again, going to those helpful errors, we see the value is borrowed here after a move. And this tends to be the most common beginner what what is going on kind of thing. So what we can see is that in this case, we had our object that we created, our string object, and in this case, I gave it to this function. So the lifetime was assumed that I have given away this variable. It is gone. Because of that, at the end of this say a thing function, if I go back over to here, at the end of this function, it sees, oh, okay, well, the lifetime of s has ended. There's nothing more here, so I'm going to free that memory. So the fact that we're trying to use it after the fact, we're saying that, hey, you specifically said that we're going to give away s. So now in this case, if I were to put an ampersand in front and say it's a reference to a string, I get a different error, which is, hey, you're trying to move the string when it's expecting a reference. So same thing, I'm going to say it's a reference. And now we can see that we're totally fine. So that ampersand is how we say that, oh, hey, we're lending out this memory. We're not fully giving it away, so we are still keeping ownership. So then that leads to the question, why is it here I'm just specifying a basic reference, whereas over here I have to give this annotation? And this is a lifetime annotation. Most of the time you're going to see basic letters. It just happens to be by convention you're going to end up seeing a lot of that. But static is a special one. And the idea is that string slices, because it's stored at compile time, the literal string is going to be stored in your binary file. And so what ends up happening is that this apostrophe static is stating that the lifetime of the string I'm returning you lives for the entire lifetime of the program. So we will never, ever free this memory. That is what's going on in this case. I don't want to get too deep into annotations. We'll see them in a couple things we're going to implement, but that's kind of the starting point. So with that all said, let's dive into making a couple more things in here. So now I would like to try adding a bit of an SQLite database so that we can have a little bit of database operability without needing to implement an entire database. So there are a number of different options we can go with. There are many different packages to do the same thing. In this particular case, I'm going to want to use SQLite, and this crate has some easy to use functions that'll let us get what we want to do. So first thing we will need to do, and this is kind of a note as read from the official documentation, is that we will need to add, where is it, a feature to this dependency to specify that we want SQLite to be compiled and bundled all together. If you have, if you're on Windows and you have DLLs for it installed, if you're on Linux, if you've got these shared objects already installed, then you're fine, you don't need this, but this will cover all our bases. So in here, I'm going to expand this dependency to provide more details. And in this case, I'm going to say that it includes the features of, in this case, bundled. So this will install our SQLite full library so that everything is good to go. When we compile this, we can start working with that type of a database. And might as well start adding some code to this. So first thing we're going to want to do, let's do it in the main function right at the beginning of the application. So we want a DB connection, and in this case we're going to want to get that from our SQLite. So SQLite, I'm going to write it out a long way and then show you a better way. So connection open, and it's going to ask for a string slice of a file name. And so in this case, I don't know, let's name it data and be completely unoriginal. There we go, and semicolon. All right, so this should make it so that we're creating our database file. Since this is automatically rerunning, more than likely we will see the file appear. And yep, that warning was okay. There it is. There's our database file. The warning was just stating that, something is causing it to rebuild repeatedly. So let's take a break from that for a second. I think I do know what this is. So the SQLite file is causing issues where the SQLite file is probably being modified, or at least it's an active open connection to the file, and that's causing the watcher to rebuild constantly. So let's add that to the git ignore. All right, now that we are ignoring that data, we can see that the application is also now ignoring it. So it respects the git ignore file insofar as what it needs to watch. Okay, so I've got my little database, and I'm going to want to, say, create a table with it. So first things first, let's try making something. So db connection dot execute. Oh, we can't do a dot execute yet. So let's go back a few steps. So we've got our database connection, but what I'm doing right now is I'm actually getting a result, because this could fail. In a lot of other languages, you'll end up with things like null value, or like in the case of C, C++, you need to make sure that the pointer you get back isn't a value of 0. Whatever it may be, the point is that it's not a guarantee that this will succeed, and so we need a way of checking that. So right now, if I hover over this variable, we can actually see that it's giving me a result of either connection or error. So in this case, what I want to do, just to kind of show you a good way and a bad way, if I really just want to kind of get it done, I can say unwrap. And what unwrap is going to do is it's going to give me the good value, or it's going to terminate the program because something went wrong. So in this case, now when I hover over this, we see it knows I'm going to have a connection, because it's going to crash the program if I don't get a connection, which I think is fine in this case because we want database access for this to run, but there are also better ways to handle this. So database connection, now let's do a database connection, and we will execute a query. And so we can see this handy thing is already kind of giving me some information. So first things first, it wants the SQL itself. So let's give a string slice. Maybe what we'll even do is, let's see, create table test. Actually, create table if not exists test. And that will just have, we'll say, one column, an ID column, and it will be, we'll say, an integer, which is also a primary key. Now, params, what it's looking for is it's looking for an array slice of things that it would accept into a query, but in this case, I'm just going to say we're going to give it an empty array. And note that even though, cannot infer type. So even though normally this would actually be okay with databases like Postgres and whatnot. The RESTQLite is a little more strict. So in this case, RESTQLite gives us a no params constraint. And the other thing is, again, if I were to run this, we can see, let me get the value, result equals, and now if I were to look at this, we can see that I'm getting a result again. And it doesn't like when, the current underlining is just because we haven't used it at all, but generally we don't want to not use a result at all. A lot of the time you'll get an error, so in this case it's going to return a U size. So let's just in this case do an unwrap, because again, if we aren't able to create this table, then I don't want my program running. I believe even in this case I won't need the variable anymore. Yep. The difference here was, again, just without that unwrap, it was getting upset that if I scroll all the way down or go over to here, we can see result might be an error which should be handled. So it doesn't like that we just implicitly decided to not worry about it, but in this case, if I say unwrap, then it totally understands that we've decided to handle it by crashing the program. Alright, so now that we're at this point, one small little improvement I would like to do that is completely optional is, in this case, I'm creating an extra scope. So we can see here I've put these two statements in these curly brackets, and basically what this is going to do is it's going to guarantee that at the end of this scope, once we've connected to our database and we have created our table, that the table is going to be dropped. So at the end of this, it sees that the lifetime of this variable is over, and it will drop that connection. Because Rocket is multi-threaded, and SQL-like connections are not multi-threaded, so we're going to open a new connection to the file every time an endpoint is hit. This isn't quite the way you would do it if this was a proper database like MySQL or Postgres, but that is totally fine in this case. And another thing I'd like to do is make this a little more useful. So instead of test table, let's call it a to-do list. We'll make a little to-do app. And let's see what we've got. Oops. Let's make it have our ID primary key, and we'll say an item, which is to do, and we'll say it can be a string of up to 64 characters. If you're not familiar with SQL, varchar is just a variable number of characters, so we're saying up to a length of 64 here. Alright, so now I'm creating my new table, we're connecting to this database, and then I know it's dropping the connection before the server starts. So, next, let's start making a new endpoint, but before we do that, there's something I want to do. So what we're going to do is we are going to load in a couple new modules. What we're able to do, let's see, SQL error, say no. Let's restart that. So this kind of goes back to what I was talking about usually useful errors. So let's see. Panicked on an unwrap because it failed. So this is actually doing exactly what we wanted, which is preventing the application from running if there's an SQL error. So near no, I probably screwed the query up. Let's see. If no, not. Oh, there we go. No null, not null. And so now this will rebuild. And this time it works. So that's again, it can be it can look like a lot. It's not always nice and colored, but generally, if you look through the errors, they will be very useful in telling you what's wrong. Okay, so we need some new modules. I'm going to add a few of these because I happen to be familiar with them. So there is a Rocket Contrib. There's a Rocket Contrib module which will give us extra features like JSON abilities. So I'm going to load that. I'm going to load something called Serialize, and that's a serializer, deserializer, so that we can work with the JSON a little more easily. And Serialize is generic, so we also need Serialize JSON. Okay, so now that those have been added, I need to add some more feature information. So the contrib needs the features JSON. Serialize needs the derived functions, and that is going to be a decorator macro that will come in very handy. It'll prevent us from writing a lot of boilerplate code that really doesn't benefit us to have to write out. Okay, that should be good. That'll cause a recompile. So kind of the status quo with a lot of Rust modules is this idea that you'll get the minimum feature set just by including something, and that's partly to prevent bulk in your program and also partly to help reduce compile time. And so it ends up being very common for you to specify which features you want. All right. So now that we have that, let's go ahead and start making some new routes. So first thing I want to make, well actually before we start making some new routes, something that we're going to need to do is, let's see, we want to
Hey, Carla.
start making these data structures that we're
Puking
going
again.
to be using. So with that in Rust, anytime we want to make a new type, some object that contains multiple fields, we're going to create a struct. Rust is very data oriented, so it breaks down into something called structs and traits. So normally in an object-oriented language you'd have classes, and your classes would contain some number of fields and some number of functions. In Rust instead, because it is data-oriented, the idea is that you have plain structures, and we'll see as I start creating some of these, and they only care about the data. So this way, the data itself almost doesn't matter. So then what you end up doing is you implement a trait against a structure. So you say, okay, for this particular struct, I want to implement this function that automatically responds or that serializes or deserializes. You pick and choose which functionality you want to attach to data objects in an attempt to keep data objects as generic as possible. And the derived function that we're about to use kind of fills in that blank where normally we would have to write a whole implementation where, oh, we want to implement this function, it has these properties, it goes through these fields, but the derive will do that for us. So let's see, I'm going to want a to-do list, and my to-do list, we'll just say has items for now. It's a dynamic array of a to-do item. Okay, so now let's make a struct to-do item, and we'll give this an ID. I64 is a 64-bit integer or an 8-byte integer that happens to be the most compatible with various SQL languages in Rust. And also, we'll say, name doesn't quite seem right. Although, if we're restricting it to 64 characters, we'll go with item. Keep it nice and generic. In this case, I'll say it'll contain a string. Let's see. Notice that the order I define these in doesn't matter. Either way, it's going to build a huge map of all the types at compile time. Okay, and one last one I'd like to create is, we'll call it status message. And this will be something we use to send responses to whenever we just want to send a message to the user. And in that case, I will just call it, give it a field message, and that will also be a string. So right now, these will not necessarily do much interacting with a new endpoint, but where these derived functions come in is, and I'll kind of show what it produces in a second. So if I were to say, okay, we're going to have a decorator on this, we're going to derive, and there's all kinds of base objects. For example, I may put debug, and that will allow me to spit out the entire structure in a print line, or there's display, or all kinds of different ones. But in this case, I want serialize, which is technically serialize, but kind of as I mentioned here, there's a better way than constantly specifying what module you're referring to. So what we're going to do is we're going to start adding those. So I'm going to put use Serialize, and in this case I know I'm going to want two, so I'm putting curly brackets, but we don't have to. So serialize, and there. So deserialize and serialize. Ooh, it's already upset about this. Why is it upset? Probably because the other one needs to be serialized as well. For example, if I look at that error, we see the trait serialize is not implemented for my item. So same thing. We can't implement serialize for the list if the items itself also don't know how to be serialized. So let's add that same thing here. And I know we're going to need it later, so we'll add the same thing for status message. So what does this derived serialize actually do? If I expand this, and we will clear this out. There is a handy function called cargo expand, and in this case what I'm going to do is, I don't think I need to put anything else. Yeah, perfect. So in this case what I'm doing is I'm saying I've expanded the whole program to be what the compiler finally uses right before compile time. So we can see even some of the rocket macros we used implemented a whole bunch of stuff. But specifically, what I am looking for is that serialize. So if I go all the way to the top here, let's see. So we've got our to-do list. And now, this is something we would normally have to type out ourselves, this whole section right here, but it's doing it automatically. So it's saying impl for implement, the serialize for to-do list. It changes the name here just to make sure that we're not doing a naming conflict. But implement it for our to-do list. The thing it's going to implement is a serialize function, and the serialize function, you can see, will automatically do some checking where it's making sure the values are correct. It's doing matches on whether the result was okay or an error. And then once all of that is complete, it serializes that struct. So because this is boilerplate code, this item, for example, is a string, this item is a number. Generally, those are really common data types to work with. So it already understands how it would handle each of those. So this is what that derived function does. Okay, let's put that back. All right, so first things first, let's make a get endpoint. So in order to do that, So in order to do that, let's make a new endpoint, which is a get endpoint. And we'll say it's the route to do. And I'm going to call this, we'll say fetch all to-dos. I'll name it a little better, to-do items. The name doesn't technically matter, it just needs to be unique. And we're going to return, I don't want to stay in the habit of doing these unwraps. It made sense for the beginning, but not further. So the alternative of unwrapping something is actually returning either an OK or an error, and Rocket will actually do a lot of handling of that for us automatically. For example, if we return an error, it knows to send back like a 400 error or 500 error. There are different ways of specifying them. They're in the documentation, so I'm not going to worry about it too much right now. But first, let's return a result, which I know is going to be JSON of my to-do list. And the second parameter of a result is the error type. And in this case, I'm just going to say when it's an error, we're just going to return a string of what that error is. So JSON, where is that going to come from? So there's another thing we're going to need to import. So I'm going to use Rocket Contrib, and then, not that one, JSON with a capital J, I think. Oh, nope, actually that was right. JSON. And you know, while I'm at it, I might as well simplify this a little bit. So this SQLite, let's take it off the connection. I'll leave it for no params because I kind of like that I'm specifying no params of SQLite. But let's do a use of this. And so anytime we have a use, you can see that basically the last component of that use becomes a name that we can refer to directly. That's what the use is doing. We can see there. Okay. So now I know I'm going to return this result, but let's see, what do I need to do first? So probably the first thing is we want to do the same sort of connecting to the database, but like I said, I don't want to do unwraps anymore. Rocket is multi-threaded, and that unwrap would crash a thread and not the whole program. So technically, it doesn't really matter. It wouldn't destroy the program, but anytime a thread panics or crashes like that, what it's going to do is tell Rocket that it should respond to the user with a 500, which is really an error state. It's not something we should be returning just because we had a problem. You can agree or disagree, maybe connecting to the database makes sense to be a 500, but regardless, we're going to change this up a little bit. So I'm going to introduce a new tool that I haven't shown before, which is the match statement. So in this case, it's a lot like a switch statement, if you're familiar with that. The match statement is basically we give it a value in, and what it's going to force us to do is deal with every possible variation of that value. So in this case, if I have an OK of connection, then I will return connection. And that return is going to the beginning of the match statement. So the connection, as long as everything's OK, is going to be returned into this DB connection for us to use. If I save this here, we can see I'm getting this error, and what this error is saying is missing match arm. So it's saying that it knows I have not dealt with all possible scenarios. Technically, I could use an underscore to say anything else I don't care about, ignore it. But obviously, we don't want to do that in this case because we do want to send an error response when that happens. So I'm going to say error. Actually, I will ignore the message for the moment. And we will say return. And just to be clear, I could put curly braces, which to me this is the way I would normally write it, but the auto formatter is going to change it on me. So again, we're returning another error. Let's see. of, let's say, failed to connect to database. And if I do this right now, I guess it's probably still mad because of whatchamacallit, not returning a proper result. So let's do that for now. Let's just say we're returning an error of unknown error until we finish this function out. Let's see what we got. Oh, missing semicolon. That makes sense because the semicolon is part of this whole let db connection equals. But now we get another error, so I'm going to go back to my terminal because, again, I want to stress how useful these error logs are. Right here, expected struct string, but found a string slice. So before, what I had showed, I think, was a string from, something like I could put string from, and then it knows to convert that into. But something you'll probably see more commonly, because it's a little more generic, it lets the compiler figure things out, is you'll see a dot into at the end of a string slice. And so that is going to automatically convert it to a string, and it knows to convert this to a string because we specifically said that anytime we return an error, the error must be of type string. So it's not like a string slice into will turn into a string always. It will turn into whatever the function is expected to return. If it can't do that, then we'll get a different kind of error. So for example, if I were to say, oh, it should return a status message, then the error we're going to get is going to say that the trait, so this is like I was talking about with functions, there is no from trait for a string slice that converts into our custom structure of status message. I'm not going to get into how you would implement this, but again, the documentation is out there, and it's actually pretty straightforward, where we'd be able to create our own custom implementation, and so at that point, the dot into would know how to convert it to whatever we want. I'll throw it into the repository at least, so you can kind of see what that looks like. But if I go back to string, those are two ways we can do it. I could even just return a string slice and then I wouldn't have to be converting it to a string, but in this case for now we're just going to leave it like this. Okay, so I've got my database connection. It's not being used, but it's valid. We know that it's valid. If there's an error, it's going to return an error. So next, let's prepare an SQL statement. Here we just directly executed a query, but in this case we're going to make a statement. Statements have to be mutable by the virtue of how they're executed. So in that case, I will say statement equals dbconnection.prepare. So I'm preparing an SQL statement, and we'll select, what was it, ID and item from to-do list. So we'll get everything out of that, and let's see. So again, this is another case where I could put an unwrap, but let's do a slightly different way. Actually, let's just leave it. I'll come back to it. Just to kind of show what that conversion is going to look like. So next I want to get my results. I will admit that this can look a little wonky. I'll explain kind of how it works, but we're going to do a query map through the results. You don't usually need to do this with other database engines, but unfortunately with SQLite, there's no choice here. So we're going to map. The first thing we're going to say is we're going to give it no params because there were no params needed for this query. And the next thing we're going to need is a closure. So in Node.js, for example, this would be like an arrow function. This is a small function that we're passing in. Technically, I could create a new proper fn function and then just give its name here, but in this case, it's expecting a closure anyway, and it makes sense to put one here. So this is expecting to get a result. What I'm going to do is I'm going to say an OK, because let's just say, this is kind of another way of writing that rather than a match statement. I could do a match statement, but you're going to kind of see another technique we could do. So in this case, I'm going to say we're an OK, and we're going to return to-do items. And those to-do items need to have an ID field, which in this case we're going to get the first parameter. I could also specify the name of the field by a string, but I'm just going to say the first parameter, and here I'm going to put a question mark. So this question mark is a lot like the unwrap, but instead of crashing the thread or panicking, instead what it'll do is it'll automatically do a return error. That's why I can kind of just shorthand, this is an OK, but when it calls this function, it's automatically going to return with an error if it wasn't able to get that field. One of the nice things too is that this also is going to do data type validation, because it knows that a to-do item must be, the ID must be an integer and the item must be a string. So if SQL returns something different, that will still trigger this question mark to return an error. Get field 1. And let's see. Oh, semicolon. Oh, right. I don't know why I thought there was an error there. So it's just 2 pipes, your parameters, and then curly braces. That is our closure function here. So I need to do something with the results, and here is a case where I'm going to do that match statement. So I want to match the results, and what are my options? My options are everything's all good, and I got rows. So if I got rows, what do I need to do? A lot of this can seem excessive, and I admit sometimes it is. Different libraries are streamlined sometimes, and some are a little wordy. I don't want it to seem like it's always this nightmare thing. There are even ways to just let the compiler tell you what type you should be putting in. But in this case, what I want to do is I want to collect all of the rows into an array so that I can return it in one shot. And unfortunately, when you're doing that, you need to, in order to collect it in an efficient way, we need to specify a type. I can't just let the compiler imply it, because when it's collecting, rather than us doing our own loop, which we totally could do a for loop here, but when we're collecting a collection, we need to specify whether it's a vec, whether it's a hash map, whether it's a whatever, because it's flexible in how it does that. So I'm going to say this is specifically a SQLite result. It may be cross-compatible with the normal result, but for now I'm specifying it's specifically their type of result, which they specify in the documentation. I want it to be a vector, and technically I want it to be a to-do item, but I'll even show another neat little thing. So rows.collect. So now that I've done that, it understands how to, what it needs to collect it into. But technically, it only really needed to know that I was working with a vec. So really, I could even put an underscore here, and although it makes it look a little funny, that tells the compiler to figure it out. And so it will infer what the actual data is. We just needed to specify that it was a vec. There are other ways to do this, something called the Turbofish Operator, where we would do something like this, but the syntax ends up being weird and complicated, especially if lifetimes are involved, so it ends up being easier to do it this way. Okay, now that I have a collection, unfortunately it's a result of a collection. I could technically do something different, but I want some good error handling here. So let's do match our collection. And what we're going to say is if it's an OK of our items, then let's return an OK of, and you'll see why I'm not actually putting the word return in a minute, but some JSON of a to-do list where items technically are equal to items, but again, we can imply that just by saying items, and it will grab this items into that items. So why are we getting errors? We're getting errors because we're still missing the error cases. Maybe even something else. Mismatch type. This is upset because we have this in place, but we're about to get rid of that. So that's okay. So when there's an error here, we will say we're going to return an error of could not collect items, let's say. And I'll do that dot into again. So this is good, but now it's, again, expecting some mismatch types because we have this extra return, so I'm just going to get rid of this. Now, because the match is the very last statement in the function and there isn't a semicolon, as I mentioned before, it knows that we're returning whatever this result is, and that's why that error went away. It now knows that we are properly matching this signature above. And last but not least, if there is an error getting the rows in the first place, we have some sort of unknown database error. I'm not going to care. In all these cases, I'm not necessarily caring what the error is. I could be getting the actual SQL error out, but I want them to be nice, plain language errors anyway. So let's say where items, we're going to return an error of, let's see, failed to fetch to-do items. And again, a dot into to turn it into a full capital S string. All right, so now we have this new method we can use, and let's quickly deal with this. So same sort of thing. There is other ways we can change this, but I think, especially for an introductory level thing, it's probably best to stick with match for now. So in this case, I'm just going to put it after here, get rid of this unwrap. And now I'm going to say the OK of statement. Yeah, that's fine. We'll return the statement, of course, and the error case will return an error. Notice we didn't have to do return at the bottom because this is the final statement, but now that we're doing up above, we need to specify it. So return an error of failed to prepare query dot into. And there we go. We now have a fully safe fetch function. It will handle all possible cases. We know it's going to handle all possible cases. We could add better handling to this if we wanted, but everything is handled. So now I'm going to add this to my routes array right here. So now we know that I'm mounting this endpoint. So let's give that a try. Here, when Rocket runs, we can see that statistics about it, but we can see here it added our new route endpoint here. So if I do a curl of localhost on port 8000 /to-do, let's see what we get. There is, I think my terminal froze up a little bit. let's see it when we actually run it here. There we go. So it matched the to-do endpoint, and it was a success, so it returned that JSON we were expecting, which is, let's see, to-do list, which returns items, which is a vector or an array of to-do items. There were no items yet in the database, so it returns an empty array. And that makes sense. All right, so next one we're going to do, let's make an endpoint to actually add stuff. So this is going to have a good chunk of repetition, so I'm going to copy this first. We can always make changes. And in this case, I'm going to say it's a post endpoint. So when we post to this, I'm going to want to specify a few more parameters, so you can see that I'm able to specify more things in this macro. So the format is expected to be JSON, and the data is expected to be given to us in a field named item. I'll kind of show how that works, but the interesting thing about stuff like this is that if, for example, the request were not in JSON format, it will not match to this next endpoint. So it's very particular about the things we specify. In that case, it would automatically send back a 404 if we were not sending a JSON. So let's add to-do item. And in this case, this is where I wanted that status message. So I'm just going to be returning a status message. We're not going to return the item that we just received. But this item here, I need a way of getting that. And so the name you put in triangle brackets is actually the name that you would specify as a variable name. It's going to automatically capture that. And in this case, it's called a request guard. There are all kinds of request guards you can make, even for user authentication, for all kinds of stuff. But in this case, for now, I'm just going to say that when we get an item in the data, not in the URL, which, to be clear, we could have totally done something like user here, and now if I specified, just before I get to this, if I specified user, maybe that's a string, maybe it's something else, my own type, but again, it will automatically match this. And if string does not match, then it considers that not the right endpoint. Okay. So in this case, I've got my item, and I know it's going to be JSON because I specified it would be JSON in the format, and I want it to be JSON of, let's just say, a string for now. We could make it a whole complex type, but I'm just going to say a string. A little overkill for accepting JSON, but I wanted to show how we would accept JSON. All right, so it's already mad. I clicked save, and I shouldn't have, because now it's mad that I'm trying to return a to-do list when it's expecting a status message. But let's see, we definitely want to keep our database connection. Our statement will be a little bit different. So instead of selecting from this, we're going to insert into to-do list the fields item or ID and item, and the values null in this case, which will tell SQLite to auto increment the ID number, and $1, and we're going to pass in that $. When we execute it. So there we go. We get our query nice and prepared. That goes into the statement. Next, we want to not map over the results because we're not receiving anything back. So I'm just going to drop this, and let's see what we will do. Let's do a statement, or no, let results equals statement. In this case, I'm putting execute. So query is about fetching information. Executing is just saying, hey, execute this. Because if we were to specify a query, it won't actually run in the database unless we then try to access those results. There are no results to access, so we're just going to say we're going to execute it. This syntax may look a little funny, but we're passing in a reference to a string or a slice, a generic slice. it needs to be a reference because we're sharing, we're not giving it away, just like we were talking about with ownership and borrowing. And then I'm going to give a reference to our item, which was specified up here, and then the .0 field happens to be what the JSON contains. Sometimes you can give fields names like we've done with ours. There are other cases where you can just specify something flat and then you get the numbers to specify. So there we're going to execute that, and now here we're going to actually match on those results. So same thing, but in this case we're going to say rows affected, because if I hover over here you can see it's returning a U size or an unsigned size. It's technically pointer size, but the point is that it is a number that we can use. So number of rows affected, which means I don't need to collect anything. I don't need to match over a collection. I don't need that, obviously. Don't need this or this or this. And in this case, what we're going to do is we're going to return a status message where the message is, let's say, format, which is kind of like the print line function. Something I actually didn't mention is sometimes there are exclamation points and sometimes there aren't. That is that these exclamation points are specifying that they are macros. Just like we were using macros up here, when we're using it not in a decorator, we're specifying that this format is a macro, so it's going to change the code before it compiles. So in this case, I'm going to make a string. Let's see. We'll call it, actually, put curly braces and then rows inserted. And in that case, we need to specify the rows affected. That's the number of rows affected. So now if I do this, it reformats it a little bit, but we can see it's going to return our message. And if it failed, it's going to fail to insert to-do item. So now we've already got our second endpoint. You can see once we get the ball rolling, it's not too bad. Maybe in the future I will do another talk and kind of show even refactoring ends up being really fast, because as you change things, Rust is pointing out where you probably need to change things. As an example, if I forgot to put the error there and I just said, oh, I'm returning this, we can actually see, actually, let's, instead of into, because into is trying to confuse it, just a small detour. So if I were to say, oh, string from, and I look at the error, we can actually see it expected a result, but it found a string. Maybe you should try returning ERR of what you returned. So you can see that you end up with very helpful error messages. It's even saying the reason for this is because we returned a result in a different match arm, so they must all be the same. Alright, so fix that. So now that the new route is here, let's go all the way to the bottom, make sure it compiles. And it does. And we can even see that we've got our new route and it's specifically accepting JSON. So let's see if I can remember how to do a curl request of this. Localhost 8000 of to do. The type will be a post type. Let's try without specifying the JSON just to confirm that. But then we'll say the data should be important thing to do. Notice I'm using two sets of double quotes. The single quotes is to say everything inside, and the double quotes inside are to say that this is a JSON string. So if I do this, we see, oh, 404 not found. No matching routes for this, because the default is www form URL encoded. So let's do a header of, what is it? I always forget how we write this. Let's put content type application JSON. Perfect. We see one row inserted. If I give it another one, we'll say another important thing to do, and one row inserted. So now in this case, if I go all the way back to just fetching, we now can see we're getting our first item and our second item in that array. So perfect. We're making good progress. Last thing we should do is being able to eliminate to-do items. So let's make one more of these endpoints. And hopefully everyone is not asleep on me and still is following. I apologize for the length. There was a good chunk of kind of going through some syntax, and then the rest. At Weever, we've found that pairing up on a lot of this stuff and seeing the thought process behind a lot of these decisions has helped with learning the syntax. So I was hoping that they would do the same here. So I don't care about receiving a body if I'm going to delete, but I do care about, let's say, getting the ID number. So as I mentioned before, we'll say an ID. It should be an I64. It should be a number. So this way, if that doesn't parse to a number, again, it's not going to match this route. Status message sounds good. Connect to the database. Here, instead of an insert into, we will do a delete from, and we'll get rid of all that, where ID equals our $1. And then we will execute this instead of with the item of string, where this is no longer a JSON, it's just an ID field, so ID. And then we will change this message to deleted. Let's see. It may not. I think that's a rows affected. Oh, right. The name must be different. So instead of add, let's say remove. And if I read the error message, it'll even tell me. Oh, expected JSON. There it is. Delete. Redefined here. So you can see it actually name mangled our function a little bit, but it still is saying that we've declared the same function twice. So let's add our last route here. And does it compile? It does. So now let's do one more. So if I take a look at what we have again, I've got 2 items. If I do a request of, let's get rid of all that data because we don't need it. We're going to say it's a delete, but we're also going to say let's delete item number 1. We see we got a message of 1 row deleted, and if I fetch them all, we can see I've only got my second item. So this is working. And to kind of show the point of some of this error handling, if I were, for example, to wipe out the database, so I will, let's say, basically clear out the data.sqlite file, and then I go to do a fetch, failed to prepare query, it understood what it needed to put. I think even we could specify, yep. So it still returned a 200 because of how we're doing it. So in the future, I would change this to proper error handling, but I'm not going to worry about it right now, so that it would return 400, return 404, that type of stuff. But we can see that it failed to prepare query because this table did not exist. We were still able to connect to it because SQLite is very flexible about it'll just create the file if it doesn't exist, but the table didn't exist, so that's why this stage failed. So now in 132 lines, we've created a little to-do app that can fetch, add, and remove. I know the syntax is probably a little bit unusual, can seem a little bit complicated or daunting, but The guarantees we got out of this is guarantees of being multi-threaded, guarantees of being efficient, no null cases, no memory cases that were unhandled. We really get a lot of benefits out of this type of thing. And when you start to write it more and more, honestly, it becomes second nature. When I use this, I find myself writing better code in other languages too, because I'm starting to think of cases where, oh, Rust wouldn't have let me do this, but I'm able to do it in JavaScript, for example. And sometimes just because you shouldn't do something doesn't mean you can't. Obviously, as programmers, we make those judgment calls, but I like having tools that will do that type of checking for me because it takes that mental cognitive load off of me. I don't need to really concentrate and think if these things line up because I know that every case is being handled. Obviously, it's not like it's mindless, but yeah. Another thing I wanted to point out is that the way we did things is not necessarily all the best. I am absolutely a beginner at Rust myself. I probably messed up some of the terminology or even butchered it by simplifying some things, but hopefully this at least kind of gives enough exposure to encourage folks to give it a try. I am going to post the GitHub repo for this so that anyone can grab it, clone it, mess around with it, do whatever you want to do. Feel free to reach out to me as well. I am always happy to answer questions. I'm usually in the Coder Camp Slack, but otherwise you can reach out through GitHub in that repo. So thank you very much for listening, and I hope everyone found it interesting. Thank you.
Wow, and we are back. And Andrew, you're muted.
How about now? Okay, so as always, Jenifer Champagne, thank you so much for the tutorial. We would love to take up a little more of your time to invite more questions in the chat on Twitch and have you answer them on camera live. So please, anybody who has questions about what you've seen in the video tonight or anything about programming, Jenifer can probably help you out. And as she said, she's always happy to answer questions. So please go ahead, type your questions into the chat. She's right here on the screen.
There is one I think I'll mention while questions come in, if they do. Threading was asked about like where the threading was in this, and so I didn't really explain that. But in this case, like Rocket is doing that multi-threaded. Every connection that comes in, it's spawning a thread and handling that automatically. That's even why we ended up not using unwraps, but if we had in the actual routes, it wouldn't have crashed the program. It just would have sent back a 500 error. So that's kind of like try-catch exception handling, like was mentioned, just that it doesn't do it in that way. It does it with results and match statements. But there is something called panic handling, which is kind of similar to that. But basically, there are a lot of cool libraries that handle that threading. There's one called Raii. And so, for example, there's a tool I built at Weever where we need to handle really massive chunks of data, and I wanted to try to do it as efficiently as possible. So what I did was I would load in 10,000 records at a time, and we didn't really see in this case, but we can do functional style coding. So it's like if I have an array and I put .iter with like a function call, that's giving me an iterator that I can now iterate over the elements. But this Raii library, instead I just put .par_iter, and it handles all the parallelization for me in a safe way. You don't have to know how to do it. So, and that's kind of that whole point of Rust, where it's trying to take those complexities away from you so that you just tell it how to do a thing. But that's why writing advanced traits, kind of like I was talking about with lifetimes and things, that's why that can get complicated, because that's the place where it needs to be correct. And the compiler helps you do that, but then after that, you're able to call these things without much thought.
Are there other languages that do that kind of thing for you?
Probably. I know Haskell has a lot of the same kind of type features that Rust has. I like Rust better, but it is closer to a non-functional language. There's probably others, I'm sure. I love Rust, and in a lot of ways, of course, I feel like it's the best at all the things, but at the end of the day, they're all programming languages. I'm sure the features are out there.
I have a
Right.
question. So this will be my first level language. So what's the biggest hurdle and what's the first aha moment?
Biggest hurdle. Yeah, that would probably be something you should tell me, because you watched the video, right?
Yeah. Well, I think probably the borrowing is at the center of it, right? So I think that would probably be that's the biggest new concept for me.
Mhm.
Yeah.
Especially if you come from a language like, I don't know C# as much. Like I know it has the VM and the garbage collector and all that kind of stuff. But like say JavaScript, where you could be very fluid about how you pass memory around. You can give an object to a function and it can do whatever, but you can still work with that object afterwards. Little things like that, especially if you're in the habit of it, really change. It makes you change the way you think about those things. For example, I had written a small library, and at first when I wrote it, it accepted Lambda functions that I was thinking of in a JavaScript way, where I could just pass it a Lambda function that could maybe add to an array where it's called. But Lambdas in Rust can't access the scope they're around because it has regular stack memory. It's not just this big collage that's going to be handled by a garbage collector. So it kind of depends on the language you're coming from, but you're right that it's basically all the hurdles, I would say, are surrounding borrowing and lifetimes, memory issues. But I think that's also the biggest benefit you get, is that once you do get used to it, you don't have to think of memory in the same way you don't have to think about it in any garbage collected language, but you know that it's being run safely.
Now that you are used to it and you've done a lot of coding in Rust and you do think about these things, do you find that when you go to code in a language that does the garbage collection for you, you're coding differently in any way?
Absolutely. At Weever, so we kind of have two main products, two main teams. The team that I'm on is mostly JavaScript based, Node.js. The other team is mostly Ruby and a bit of TypeScript. So a lot of what I would do day to day outside of making the Rust kind of backend tools is JavaScript related. And in that case, there are times when, for example, error handling. I wrote it ended up being like 20 lines of JavaScript code, but I wrote a result type that I use in the exact same way, and I can do matching against it in JavaScript, because like normally we would use promises or we would use exception handling, but if you have a catch in a place where you didn't expect it, now your error is not getting to the place that you wanted it to get to. So then you end up having these like transparent errors. Instead, I'm just working with this result type. And every time a function returns, it's going to get that result type. It's going to know where the error variant came from or if things are okay. So the maybe type and the result type is something I've brought over to JavaScript. And there's definitely a lot of cases where I was like, Rust wouldn't let me do this. Should I be doing this? And honestly, most of the time it's no.
Mhm. I see that Garnet in the chat is saying that he wrote a result type with an anonymous type there in C#. Jen, you've done a lot of, sorry, Jen Armstrong, you've done a lot of C#.
Yeah.
Can you comment on that?
Probably not very intelligently, but I did recently this summer in my co-op. I learned a little bit about maybe types and monads. Am I saying that right? Yes. So yeah, those are brand new to me. I have never actually used them in code, but now I know what they are.
Nice.
Cool.
And we didn't really use a maybe type today, but I think I mentioned in the chat that a lot of this ends up breaking down to either the result type or an option type, and an option type is a maybe monad.
There you go.
Cool, cool. I'd just like to say to everybody who's watching, if any of you are, you know, first semester, second semester, and you're thinking maybe you don't, if you feel like you don't know enough about programming, and maybe because this is a language that you weren't familiar with, you feel like your questions aren't relevant, please flip that thinking. Anything you want to ask right now is completely relevant. As Jenifer herself said a few minutes ago, they're all programming languages, and they all share the fundamentals, right? So anything you have a question about that you saw tonight could very well be the exact same thing you're going to encounter in any of the languages you're learning right now. So please go ahead and throw questions in there. Anything at all. Rodney, do you have any questions?
Yeah, actually, hey, Rodney. I was actually wondering what resources besides like the Rust docs would you recommend for somebody to get started learning about it?
So there is the official documentation, and then there's a few Rust books, which are really HTML-based books on websites. I've linked to a couple of those resources in the README of the GitHub repo, but if you just look up Rust book, you'll probably find them. And then there's another one called Rust by Example. And both of those are extremely detailed. I think before I even, not that I'm recommending this, but before I even wrote any Rust code, I had read through most of the book a few times, just trying to kind of understand the concepts. So then by the time, I had totally psyched myself out that it was going to be super complicated because everyone hates ownership and borrowing at first. But my first few times went super smoothly. And then I hit that Lambda thing I was talking about where it totally didn't work the way I expected and had to completely rewrite the library. But yeah, it wasn't that bad.
Cool.
Okay, well, let's take this last question that we see in the chat from CDP1802, asking what's the smallest microcontroller you can run Rust on, or that you have run Rust on?
That's interesting. I've only run it on, I think it's an ESP8266. So there's that one and a couple different Arduino chips, but I haven't necessarily tried to run it on like a super, super tiny microcontroller, but I would say the Arduino Mega and the ESP8266 I have successfully run it on. And they're fairly small. I think the ESP is something like 4. I don't want to screw this up. It's either 4K or 4 megs of memory, but 4 megs really seems unlikely. But it's a small chip.
Cool, cool. All right, Jenifer, we want to thank you for your time. Just to clarify for everybody watching, Jenifer didn't just spend a couple of hours here tonight. She spent all that time making the video for us, all the time planning what we were going to talk about. She is really a true friend of the new developers. This is the second time she's done this for us. And I would like to point out that we do have some things in the works, some more collaboration between the new developers and Jenifer Champagne and the folks at Weever Apps. So there's going to be some things coming up in 2021. For all of the Mohawk C-State students watching tonight, please keep your eye on our site and get on our mailing list to find out what's happening. We'll release details as they're decided. So, Jenifer, thank you so much for tonight.
You're very welcome.
I would just like to, sorry, I would just like to take a couple minutes here just to make a couple of announcements. First of all, about contacting us, if there are any students who want to join our mailing list, maybe Jen Armstrong, could you drop the URL up there on the chat? Join our mailing list. You'll get direct emails telling you about upcoming events from the new developers. Also, if you didn't get the GitHub link for Jenifer Champagne's code that you saw in the video tonight, perhaps Jen Armstrong could drop that in as well, and just go there, download your own copy of the code, and take a look at it. Also, if there are any Mohawk students out there who are not on the Mohawk CSATE Discord, please send us an email, and we'll send you an invitation link. And Jenifer Armstrong has dropped in the email address in the chat. Send us an email. We'll get you set up on the Discord. The Discord, if you're not familiar with it, it's got over 300 students on it, and we have channels in there for all of the courses and all of the semesters of both streams, the networking and the software. It's a really great place to be, to make some social connections, to get help when you're having trouble with assignments. It's changed my life, to be sure. Also, just quickly, what we know about the social event. We had big social events at the beginning of the winter semester, the beginning of last fall semester. We didn't do it at the beginning of this semester. We're doing it in December. The idea being, when we're done our exams, we can just relax, have a good time. We've got some stuff planned. We think it's going to be great. It's all online, of course, but we'll send the details to everybody when we have decided everything. It'll be up on Discord, and we'll go out to the mailing list. So please keep an eye out for that. Sorry, just looking at my list here. Any of the students out there who are going into second semester or later in January, please consider helping out with the new developers. We need more people to help organize these events, to meet with Jenifer Champagne, talk to her online about what you need to know, what you want all the other students to find out, things that aren't in the program, right? Rust isn't in the program. Jenifer Champagne said, I'd love to teach you Rust. And we were like, let's do it. So please, if you would like to, spend a little time and dig deep into the new developers and help organize these events, we really would love some new blood, because a lot of us are graduating in December, so we need some fresh people. So contact us, okay? The email address is up there. The site URL is the TND site URL up there somewhere. It will be in a second. And finally, I would just like to say that if anyone watching tonight has developer positions in their company that we might be able to help you fill, there are a lot of skilled, motivated developers graduating from the Mohawk program next month, including me and my fellow New Developers Club members. Actually, the two you see on screen, they're already spoken for, but there are several who are very capable people. And if you're interested in meeting any of us, please contact us at the email address or through Twitter or any of the methods on screen there. So we'd love to hear from you. That's all I have to say for tonight. I want to thank everybody for joining us. We will try to get this video up on YouTube later. That's a possibility, right? We're hoping.
Yeah, I will actually hopefully upload this one and our previous one to our Twitch channel. Maybe to YouTube as well, but at least here.
Okay, see what we can do. Nice. All right, anybody else? Any last words? Anything?
All good.
Okay, thank you very much, everybody. Thank you, Jenifer. Thank you, all the viewers in the chat, for all of your great questions. We will see you again soon. Stay in touch. Thank you very much. Good night.
Take care.